Okay, welcome to this series of lesson in Introduction to Elementary Physics. This is lesson 1 of the topic vectors. Lesson 1 is broken down into 3 parts, which are parts A, B, and C. This part A of it is just like an introduction. So at the end of this part A, you should be able to define a vector and give some examples of vector quantities. However, the topic vectors as treated here does not capture the entirety of everything about vector theory. It only seeks to give you some basic ideas of what vectors are and how to find the resultant of vectors. So do well to subscribe to this channel and also hit the notification button so that you will get updated anytime new lessons are uploaded. Thank you very much. So let us begin. What are vector quantities? These are physical quantities that have magnitude and direction. Very importantly, anytime you are defining a vector, you should mention magnitude and direction. If these two terms do not appear in your definition of a vector quantity, your definition will be counted as inaccurate. So without any specified direction, a quantity may not be regarded as a vector. Examples of vectors: we have displacement, velocity, acceleration, force, impulse, momentum, torque, moment, position, magnetic field, electric field, gravitational field, etc. There are several examples, but these ones are the ones you always come across more often. Okay, so why are these vectors? Because they are characterized by both magnitude and direction. In other words, anywhere you see any of these quantities listed, magnitude and direction are embedded in what they represent. Okay, that being said, there are a few quantities that may appear as if they are vectors, but they are not vectors. These include pressure, work, energy, and power. These are called scalar quantities. Scalar quantities are quantities that have only magnitude but no direction. When we say magnitude, we are talking about how big or how small a quantity is. That's talking about the size of the quantity. So our focus here is vectors. So we won't say much about scalars. But why are we mentioning this? If you look at pressure, the formula for pressure is force over area, and the formula for work is force times displacement. You can see that force is a vector quantity and is appearing in the formulas for these quantities, work and pressure. So you may want to think that work and pressure are vectors. Meanwhile, they are not vectors. The proof as to why they are not vectors is not captured in the scope of this lesson. The same thing goes for energy and power. They are scalar quantities. So this brings us to the end of part A, the introductory part of this lesson of the topic vectors. Do well to hit the subscription button and also the notification button so that you always get alerted anytime new lessons are updated. Thank you very much. See you in the next lesson.